t to the 23rd is. Like, if I were to write this out, t to the 23rd, I don't know what it is. Oh, that sucks. Great. I better go home. But wait a minute. I can't go home yet, because I could probably figure this out. Do I know what t2 is? Do I? Well, I know the answer. It's going to be 4. Okay? But more importantly, do I know the formula for t2? And the answer is, yes, I do. It's actually the same formula that I have for t23. It's going to look something like this. n minus 1 times d. Right? And do I know these? Well, I still don't know the a, and I still don't know the d. But I do know the n, and I do know the answer to this. Well, this one, t2, is actually going to be equal to what value? 4. Hang with me, guys. This is going to work out for you. Trust me. T to the 5, I'll expose to the same equation. Okay? I still don't know my a. I know my n. I don't know my d. And I do know my answer. This one's going to be 22. Okay? 22. So I can simplify this further. I can rewrite this where t2 equals a plus, and remember, 2 is my n. I can sub it in. It's going to be 2 minus 1 d. And t5 is going to be a plus 5 minus 1 d, right? Think about it for a minute. All I did was take my n, which is 2 here, sub it into my formula, take my 5 here, which is my n, sub into my formula, and I could break this into what we call a system. Now, for those of you guys who forgot what systems were, systems allow us to find two unknowns at once. I'm going to pause here. I'm going to see, can you guys figure out exactly what A and D are? If you can figure it out from here, that's awesome. Okay. Well, I paused for a few seconds. I hope you learned it. Let's figure this out one way right now. I'm going to bring these calculations over here. I don't like to bring things backwards like this, but it'll work out. Okay, so I have A plus D equals 4, and a plus 4d equals 22. Is there a way? First of all, what do you want to eliminate? I probably want to eliminate the letter A. It'll work out very well. But in order to eliminate the letter A, I probably have to multiply everything here by -1, don't I? And when I do, I'm going to get the following, okay? I'm going to get A plus D equals 4. But once I multiply everything by -1, I'll end up with a -a minus 4d equals -22. These guys can add up, can't they? And when they do, these guys sum to be nothing. These guys sum to be minus 3d. And these guys sum to be -18. Can you solve for d now? I sure can. Well, you can too. I divide everything by -3, and d equals 6. And if d equals 6, I could probably solve for my a, could I not? Because remember, t2 equals a plus d equals 4. I know my d already, so really this is a plus 6 equals 4. Or if I subtract 6 from both sides, a equals -2. So I have my d, and I have my a. Can I plug them into here now? I totally can, and I will. Let me just move on to another piece of paper here so you can see it. What's going to happen is the following. I'm going to do the following here, okay? Let's do it like so. I know that t to the 23 equals a plus n minus 1d. I know that my a, we solved it right here, was -2. I know my n for t23 is 23. I'm going to subtract the 1. And d is 6. So when I do this, it's going to be -2 plus these guys subtract. It's going to be 22 times 6. All right? And my answer here, and I got to do it the long way, I guess, 22 times 6 is going to equal 132. -2 plus 132 is going to equal to 130. This is my answer. My 23rd term is equal to 130. Okay? That's what it is. So if I were to go back to, say, this sequence that I had initially, I'm going to move this down a bit. This term here is actually going to be 130. Okay? And that's how you do this problem. Hope that made sense. Thumbs up if you got it. Sorry, nobody's watching. All right, let's move on. So let's do example 4. I'm going to give you guys another example right here. example 4 works like this. It's going to be find T6 for 3, negative 12, 48, dot, dot, dot. Okay? And if you think that this sequence kind of looks familiar, yeah, it's one of the same ones we kind of did in example 2. But give it a shot. I'm going to pause right here, and you should pause the video and see if you could solve for this one. Look at your formula sheets, figure out which one works. Did you find it? Well, truth be told, okay, you have what's called a geometric sequence again. Remember? And if you remember this one right now, I'll write the sequence again a little larger. Okay. You can tell a couple things. You know what your common ratio is. And remember what it was? This one was negative 4. This one is negative 4, and so forth and so on. Okay? Remember what your A was? Your A here, in this case, your A equals 3. So really what we've done here is we're in a really good shape, guys, to actually solve for our T6. Now, remember, for your nth term of your geometric sequence, and I'm just going to call it GS as a acronym, because I'm not going to keep writing that down. Your nth term is going to equal A times R n minus 1. Can I plug those numbers into here? And the answer is yes. Okay. Do I know my A? Yep, it's 3. Okay. I'm going to write it down right here. It's 3. Do I know my R? Yep, know that too. It's going to be negative 4. Do I know my N? Well, what term am I interested in? Well, the 6th one, isn't it? So if I use the 6th one, it's going to be 6 minus 1. Of course, these bases can't multiply. I have 3 times my negative 4 is to the 5th power. Okay? And if I don't work this out, it's going to be a massive number. Oh, boy. It's 16 times 16 is 256. 256 times 4 is 1024. Yeah, I think I did that right. And I'm going to take this 1024, I'm going to multiply it by 3, and I'm going to get my number, 3072. My answer is 3072, and I think it's going to be a negative, because I had to multiply by negative 4. My answer is negative 3072. Notice what happens when I keep multiplying by a negative number, and why this is negative. It totally makes sense. I'm sorry, let me scroll up a bit. I'll repeat myself. So, one more time, I took 256 and multiplied by a negative 4, I ended up with negative 1024. That got multiplied with 3, I ended up with negative 3072. I'm going to, again, one more time, why does this make sense to have a negative number? Well, truth be told, you have an odd exponent. An odd exponent with a negative sign inside here. That's why we end up with the 6th term of negative 3072. So, for this to happen, you actually had to keep doing this several times, a 3rd time. Okay, right? A 4th time equals negative 4, right? This would have been T2. This is T3. You would end up with a T4 here, a T5 here. And if you did it one more time, you would have ended up with your royal value of negative 3072, which makes sense. You see how this one would have been negative 2. These values alternate between negative and positive numbers. That's also a telltale sign of a geometric sequence. Okay, so that's that one right there. Let's do another one. Good job. You guys are hanging in with me. That's awesome. Let's do a 5th problem. Example 5. And I'm going to let you guys do this one on your own, and of course I'll help you solve it. Find T7 for a geometric sequence in which T2 equals 24 and T5 equals 3. Okay, so we're looking for a geometric sequence, guys. All right, and I'll write this for those of you guys who don't know. These are my initials, actually. Geometric sequence. Okay, let's figure this out. I mean, this is good. We'll be able to pull this off. So, I'll pause for a few minutes, a few seconds, and you should hit the pause button and see if you can solve for this. Great. So, let's try to do this together. Remember, your nth term for a geometric sequence is what? It was A times R n minus 1, right? So, right away, we want T7. It's going to look something like this. T7 is going to be A times R, okay, 7 minus 1, which is really going to equal this, A times R to the 6th. Okay? And then you start looking at your options. You start looking at your options, go, well, I don't know A because I don't know my T1 and I don't know my R. If I were to write this thing out, if I were to space this thing out, it would look something like this, wouldn't it? It would be T1, and then it would be my 24, okay? Then it would be T3, T4, and then it's going to be my T5, which is 3. I still don't know this. Do you remember the strategy we used in the previous examples? Do you? Well, what I have to do is I basically have to know that I possess in my possession a T2 and a T5 already. I know my second term and I know my fifth term. All I have to do is apply the formula. So here my T2 is going to be A, R, n minus 1. My T5 is going to be A, R, n minus 1. And I just got to start plugging in my values, okay? Because I know this is going to be A, R, n minus 1 is going to be 2 minus 1, right? This one down here is going to be A, R, my n here is 5, so it's going to be 5 minus 1. I have AR here, and I have AR to the 4th power there. Okay, and I know all these values, okay? Because what I'm going to say then is the following. I'm going to bring this down. T2 is going to equal AR, okay, which I know the value. It's going to be 24, all right? And then T5, I know this value. It's going to be AR to the 4th power. I know this number to be 3. So there's a lot of ways we can solve for this. We can substitute, we can divide, we can do all sorts of stuff. But bottom line is this: we can probably do it this way. What happens if I just divide these guys? Divide. What happens when I divide it? Well, let's figure it out. If I divide, and I'll rewrite this thing one more time down here so you can see it. I have A to the R over AR to the 4th power, and I have 24 over 3. Can I start canceling out some of these terms here? For those of you guys who can see it, these A's are gone, right? And if I have one R on here and 4 R's down here, this one cancels, and this becomes an exponent. You end up having 1 over R cubed equals 24 over 3, right? So far, so good. And if you were to do some cross multiplication, so this here is cross multiply. And for those of you guys who are wondering how I got this, I'll repeat myself. Basically here, I cancel exponents. All right. And for those up here, what I did was I basically divided. Okay. I divided, I put a division bar here. I took T2, I divided it by T5. And T2, you know here, is A to the R. I divided by AR to the 4th power. And I know that T2 is also 24. I divided it by 3, which is T5. So what I did was essentially take this ratio, divide it 24 over 3. I end up with something like this. After cross-multiplying, for those of you guys who don't know cross-multiplication, go find your middle school teacher and tell them that they didn't help you. And you have 24 over R cubed. What you can do next, though, divide by 24, and you end up with 1 over 8 equals R cubed. What is the possible value for R? In that case, if you know this, R is actually going to equal 1/2. I now know my R. This is one of the strategies you could use, and I'm feeling pretty good about it. Okay? Now that I know R equals 1/2, do you think I could solve for A? Well, truth be told, I can probably figure that out. Because remember, T2, I'm going to write it down over here. T2, remember, is equal to A times R, and it was equal to the number 24, right? Well, I know my R. My R is actually 1/2. If I were to take this thing and plug it all the way back into here, I'll be able to figure it out. It's going to be this: A times 1 over 2 equals 24, or A over 2 equals 24. My first term then, my very first term that I worked with, is going to be A, then is equal 48. That's my first term, okay? So if I were to go all the way back to my original sequence up here, this one was actually 48, okay? And of course that makes sense now.